Welcome to Spring Lib.
Okay, so we need the frequency of electromagnetic radiation in order to promote an electron from n equals 2 to n equals 4. Okay, so we're going to use the Bohr model, and that is going to tell us that, or the Bohr transition equation, which tells us that delta E, or the energy related to a transition from one Bohr model orbital to another, is equal to negative 2.178 times 10 to the negative 18 joules. That's a constant, times the quantity, so in parentheses, 1 over n final squared. So that's like where we end up, where the transition is 2, minus 1 over n initial squared. Okay. Now this will give us an energy. We've been asked for a frequency, but recall that frequency times Planck's constant is equal to an energy, or another way of saying that is that frequency is equal to energy divided by Planck's constant. So if we can calculate the energy and divide it by Planck's constant, we will have the frequency, or we can just set the equation up like that and say that delta E, sorry, not delta E, that nu will equal delta E over H. We'll have the equation for delta E right here, which is really just to say that this entire equation divided by H, right, will give us the answer in terms of frequency. So frequency is equal to negative 2.178 times 10 to the negative 18 joules divided by H times 1 over n final. Well, here that's going to be n equals 4 because we're going from 2 to 4, so our final position is 4. So 4 squared minus 1 over n initial, that's 2 in this case because we're going from 2 to 4, 2 squared. Okay, and recall that Planck's constant, let me make some space here. And the units that we need it in is going to be 6.626 times 10 to the negative 34, and that's joules. Sorry, that's a 4. Joules over hertz, or joules times seconds. So notice that a final answer, these joules will cancel and we'll have per second, which is good because frequency should be 1 over seconds. Okay. So at this point, we can just plug this in the calculator. One other simplification we could do is to say that, 1 over 4 squared is 1 over 16. 1 over 2 squared. So 1 over 16 is 1 over 4 minus 1/4. Okay, so this is going to be negative 3/16. Okay, so now we can put negative 3/16 in place for this parenthesis. But the rest can go in the calculator as is. So 2.178, negative 2.178 times 10 to the negative 18 divided by 6.626 times 10 to the negative 34. All of that times negative 3 divided by 16. And we get that nu is equal to 6.163 times 10 to the 14th per second, so seconds inverse. Right, so every second, or the frequency of this is 6.163 times 10 to the 14th for every second, which just means that every second this happens, right, to the wavelength or to the particle in terms of its amplitude every, I don't know, that's like billions of times per second.